Hello, students. This is Mr. Guzzi here. I'm going to be explaining the new car activity group thing that we were working on in class. So if you missed it or you didn't get if it didn't fully make sense, hopefully this will help make more sense. So a couple things first. This is the same equation we were working with last week, except that it's now minus. Okay, and that's because your car is not going to increase in value; it's going to depreciate, which means it won't be worth as much after several months. So we have all the information we need. A is still the same. That's still our starting amount. Okay, that's just from the equation. 1 minus R. The key thing here is R. 1.5%. Oops, let's move that over a little bit. When you move the decimal 2 places, you end up with 0.015 as your decimal. So you moved it 1, 2, and again, the whole reason for that is 1.5%. Really, what it translates to, it means 1.5 per 100. So really, this is what percent means, and then so when we change it, it should be that decimal. Okay, 0.015, and then t is the time. In this case, it's 48 months, so it's 48. Okay. Now you'll need a calculator for that part. So here's what we got. 18,500, 1 minus 0.015 to the 48. Now the key thing here is the minus and then also the decimal. If you're off, you're going to know it because your answer will be thousands of dollars different from someone else. So get that, and you got about 8955.93. 8955.93. And we'll round it out there because this is dollars, so it doesn't really make any sense to go more than 2 decimals. So, okay, so 8,000. So right there, that's one of the key ideas. You bought a car at 18,500. 48 months later, the best you can hope to sell it for is probably somewhere around 8,900. So it's sort of dropped by about half. That's the power of 1.5% per month. Over time, it gains speed. 1.5% doesn't seem like a lot, but it's going to lower the value of your car. Okay. So most people got that. Here's where sort of the challenge came in for some people. Was question number 2. Okay, so I want to highlight a couple things there. All this junk in here, we have values for I, we have values for N, A, and R. Or no, we don't have R. R is what we're searching for. Okay, so we have all those other values. So a couple things we need to make sure of. 12.5% would be 12.5%, which again, as a decimal, is 0.125. Okay, so here's what we're going to do. I'm going to take a separate piece of scratch paper and try and calculate this thingy. Okay, so it's A equals R. I'm going to put another set of parentheses around this thing just to group it better. 1 minus 1 plus I was 0.125 over 12. N is 48, so we get negative 48 up there, and then 0.125 over 12. So essentially all we've done here is just plugged in all the numbers that they gave us. The problem is, how in the heck do you deal with this thing? So it's not as bad as it seems, mainly because we can only do one thing at a time, and we're going to do those things following PEMDAS. So PEMDAS says inside the parentheses, so cover that up. Oh, there's more parentheses, so cover up everything that's not those parentheses, and sort of everything except for that little part there. So that's just 1 plus 0.125 over 12. All right. Clear? 1 plus 0.125 over 12. That's it. And so we get 101 point blah, 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 blah. Okay. So that's that first part. 101 point blah, 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 blah to the negative 48 power. So we're going to raise that answer to the negative 48 power. And this calculator is nice because I don't have to type all that. It keeps all of it stored as my answer. And so that's what I get. So that's just the first part. Okay, so let's write this down again. A equals R, 1 minus, we did this whole thing here and got 0.608, blah, blah, blah. We'll just keep that much of it. Okay, so all we're doing is one thing at a time. So we did this in the calculator, did it to the negative 48 power, and that gave us that. Okay. Let's change that. Okay, so let's continue. 1 minus 0.08, blah, blah, blah. So R, 1 minus 0.608, 1 minus 0.608. Again, the calculator is going to do most of the hard work for you. That's 0.392. The bottom is 0.125 divided by 12, 0.0104. All right. That, then we divide. Again, like I said, it's a lot of steps, but the calculator is really doing all the hard stuff. So, all right, 37.69. That's what we're after. So A equals R times 37.69. Okay, that's not our actual answer. Now we got to solve this. What we've been after is R. A was the starting amount, so if we change that now to the starting amount, 18,500 equals R times 37.69. We're after R, so if we divide this, those cancel and you get R equals that. 18,500 divided by 490.84. That is R, and what the heck is R? If you go back and look, R is the monthly payment. So after all this work, we found out that's your value of R. Okay, so let's jump down to the second part of this paper. And here's the idea. We did all this stuff, and we got R is approximately 490.84. So I'm transferring that answer over to here so we can use this paper now. So now, the total is going to be the monthly payments, that was this, 490.84, times the number of months, which we said was 48, which will equal 490.84 times 48, 23,560. $23,560.32. Is that a lot? Well, here's the deal. Your car was only worth $18,500 to start with. By the time you finish paying for it, it's worth, you've paid this much, and you're definitely not going to be able to sell it for anywhere near that. That's the main idea here. Okay, so what we're after here is how much you're paying per month, how much you still owe, and all those kinds of things, so we can tie it back into the gap insurance that we started talking about at the very beginning with the video. So final thing here. A linear equation is just this thing, but instead of total, that'll be our y. 490.84 that's constant. That's our monthly payment. What changes is the number of months. Maybe I want to know 1 month or 2 months or 10 months. That's why I put it times x for x months after x months. So that's one of the equations we're going to need for the back side, as well as this equation for the back side. Oops, there we go. And we'll do both those tomorrow on Desmos. So if you got to it already today, you're in great shape. If you didn't, we're going to throw those into Desmos. Thanks for watching, and check out tomorrow's video. Will have us doing the Desmos part. So if you need to catch up on that, we'll do that. Have a great afternoon, and good luck with everything else.